All right, welcome to section 9.4, and in this section we are going to be writing absolute value and quadratic word problems. So we're going to apply this to some real life situations. So example 1 says a machine is used to weigh each of several bags of 16 ounces of sugar. So I'm going to underline 16 ounces. After the bags are filled, another machine weighs them. If the bag weighs 0.3 ounces more or less than the desired weight, the bag is rejected. Write an equation to find the heaviest and lightest bag the machine will approve. So we're really looking for some sort of range, the highest, and the lightest that it could approve, which is going to give us an absolute value equation. Absolute value always is like the distance. In this case, it's the weight distance from 16 ounces. So the first thing we want to do when we do these problems is label our variables. So I'm going to say x equals the weight of the bag. And then once we know that, we're going to write these absolute value equations. So x is going in there, and it's always going to be minus, okay? Because we're going to put our desired inside here, our desired amount, what we're trying to get. And in this case, our desired amount is 16 ounces. And the reason why we did minus is because we're going to have to add it to the other side, and we want it to be positive. On the other side of the equal sign is going to be our level of error. That's our more or less. So in this case, it's saying 0.3 more or less. So I'm going to say 0.3. So our equation to match this situation would be the absolute value of x minus 16 equals 0.3. So that's our equation. Then to solve that, to find the maximum, I'm going to undo that absolute value. Remember, to undo an absolute value, we write two separate equations. One where the right side's positive, we drop that absolute value. And then we drop the absolute value and make the right side negative. So when I solve this, I'd add 16. And one answer is going to be x equals 16.3 ounces. And then, so that's our maximum. The minimum, we would add 16 again. And we would get 15.7 ounces is our minimum. Okay, but the key is when we have that like min-max thing within here, we're using absolute value. We're doing our variable minus whatever our desired amount is inside of the absolute value and setting it equal to our level of error. So as we go to our next problem, it says a thermometer comes with a guarantee that the stated temperature differs from the actual temperature by no more than 1.5 degrees Fahrenheit. Write and solve an equation to find the minimum and maximum actual temperatures when the thermometer states that the temperature is 87.4 degrees. So again, we have this minimum and maximum thing going on. So we're going to say x equals the temperature. And so we're writing this absolute value. Inside the absolute value, we have our x. We always have minus. Our desired amount is what the actual amount should be, which is 87.4. And then our level of error is on the other side of the equal sign, which is 1.5. So that is our equation. And to solve that, we would undo our absolute value. So we would have x minus 87.4 equals 1.5. And then we'd also have x minus 87.4 equals negative 1.5. So when we add 87.4 to both sides, our maximum will be x equals 88.9 degrees Fahrenheit. And then again, we would add 87.4 to negative 1.5. And 87.4 minus 1.5 is 85.9. So our minimum would be x equals 85.9 degrees Fahrenheit. All right, so that's our absolute value. Again, we're looking for like a minimum max to get the absolute value. Example 3, we're getting into the quadratics. It says Kelly built a model rocket and launched it. The rocket's path can be described by the equation h of x equals negative 16x squared plus 176x, where x represents the time in seconds the rocket has traveled, and h of x represents the height of the rocket in feet. How many seconds into the flight will the rocket be when it reaches a height of 448 feet? So again, x represents time, h of x, which is just function notation, is the height. We want to know how many seconds would it be when it's 448 feet high. So that means we're replacing the h of x, the left side, with 448. And to solve this, we're going to have to go back to our unit 4, because we're going to have to factor this or use the quadratic formula. Well, I'm going to factor it. Remember, in order to factor, you have to set it equal to 0. So I'm going to subtract 448 from both sides to make the one side 0. And so that's going to give me, on the one side, I'm just going to switch sides here, negative 16x squared plus 176x minus 448 equals 0. And so we're going to factor this. And in order to factor, we always want to look for a GCF first. So there's a 16 in front. So I'm going to try and divide each of these by 16. And if I try 176 divided by 16, I get 11. And when I do 448 divided by 11, I get 16 when I do 448 divided by 16, I get 28. So I am going to pull out a GCF of 16. But not only am I going to pull out 16, I'm pulling out negative 16 because remember, we always want our leading coefficient to be positive. So I'm going to put a negative 16 in front of one set of parentheses. And then divide everything here, all my original terms, by negative 16. So I would end up with x squared, because negative 16 divided by negative 16 is equal to 1, positive 1, minus, when I do 176x divided by negative 16, I get negative 11x. And when I do negative 448 divided by negative 16, I get plus 28. Which now I can use my SAM factoring to factor this. So the negative 16 is going to stay in front. I make my two sets of parentheses. I have my x and my x. I'm saying what multiplies, again, this is an m here. What multiplies to 28 now is the negative 11. So that would be 7 and 4. And they both have to be negative. Negative 7 times negative 4 is positive 28, but when I do negative 7 plus negative 4, I get negative 11. Set that equal to 0, and then I use my zero product property to get each of my factors equal to 0. So I set 16 equal to 0, which is not going to give us an answer because there's no x in there. X minus 7 equals 0, and then x minus 4 equals 0. So that's going to give us two answers, x equals 7 and x equals 4. Remember, that's in seconds. So why is there two answers for this one? Well, if you think about it, this is going to be a parabola. The rocket's going to come up, and it's going to come back down. So when it's coming back up, it would be at 448 at 4 seconds in, go all the way to the top, and start coming back down. It would also be at 448 on its way back down at 7 seconds. So we'll say the height is 448 feet at 4 seconds and 7 seconds. All right, we'll do one more. It says the Bash Music Department is selling concert DVDs as a fundraiser. The total profit P depends on the amount X that the music department charges for each DVD. The equation P equals negative 8x squared plus 484x plus 1,200 models the profit of the fundraiser. What is the least amount the music department can charge for a DVD to make a profit of $200? So it says X is the amount we're spending, and we want to P is the profit, so we want to put 200 in for the P. All right, so we got negative 8x squared plus 484x plus 1,200. All right, so just like above, we're going to have to get it equal to 0, so I'm subtracting 200. And I get negative 8x squared plus 484x plus 1,000 equals 0. All right, so now I'm going to factor out our GCF. So 8 is in the front, but 8 doesn't go into all the numbers. So we have to figure out another GCF. It's not 8. It would be 4 in this case. So I'm going to put a negative 4 in front. Again, we always want our leading coefficient to be positive. That's why I'm pulling out a negative number. So I get 2x squared minus 121x minus 250. And now I have to factor that. Well, I can't do SAM because there's a 2 in front. So I'm going to have to do our slide divide bottoms up. So I'm going to write this as negative 4. I'm sliding that 2 over. So I get x squared minus 121x minus 500. And so I'm saying what multiplies to negative 500 and adds to negative 121. And when we go through all of our options here, we'd be at 125 and 4. Because again, I'd start with 1. 1 in 500 wouldn't work. 2 in 250 wouldn't work. 3 doesn't go into 500. But when I do 4, I get 4 and 125. And when I subtract them, I get 121. So I'd have x minus 125 and x plus 4. So then I divide and bottoms up. So I divide each of the numbers here by what I slid over, which was a 2. I get negative 4. 125 over 2 does not reduce. So I write this as 2x minus 125. And then I can do 4 divided by 2 and get 2x plus 2. And that's equal to 0. So now I'm factored. I set each of my factors equal to 0. Well, negative 4 cannot equal 0. I would do 2x minus 125 equals 0. And then x plus 2 equals 0. All right, so this one's the easier one. I get x equals negative 2. And then here I would add 125. And then divide by 2. And 125 divided by 2 is $62 or $62.50. Now, we got to go back and think about the context of this problem. X is the amount we charge. We're not going to charge negative $2, and you're not going to get a profit if you charge negative $2. So that's not going to be our answer. So our only answer is this one that makes sense for this context, and we'd say $62.50. That's how much I'd have to charge per DVD to make that. All right, so again, when you're doing the absolute value, make sure you're looking at the whole in the parentheses, your variable minus your desired amount equals the level of error. And when you're doing the quadratics, remember you are going to have to get it equal to 0 first. So once you plug the number in for the y, get it equal to 0, move it to the other side. And then you are going to have to remember how to factor. Please like and subscribe to my channel. Thank you.